Now we are going to start with the machine learning. Machine learning is a very important topic inside the business analytics in R. So let's learn about the machine learning now. Machine learning is a kind of a learning where the machine learns the data. Now, how we can understand that how the machine can learn the data? Just we can assume like a small child, whenever a small child steps into the school first time. So initially the student does not know anything. But later on, after some days or after certain weeks, the student or the small child will start learning small things such like the A, B, C, D or 1, 2, 3, 4. And slowly the child will start making certain words such as cat, rat, mat, bat. So the point is, like the child is learning with a slow growing process, in the similar way, machine also learn the data. So whenever we are talking about the machine learning, it means machines are learning the data slowly, slowly, slowly. And now if we simulate the machine learning with the child again, so like the child initially learns, some data or the text provided by the teacher, and later on, once the child has learned the given text, the given syllabus, then the teacher can take the test as well. The same happens with the machine learning. We initially train the machines with the data. Machine will start learning the data, and later on we can take the test of the machine as well. So basically this one is the basic definition, technical definition of the machine learning. That machine learning creates the knowledge. It is a changing in the system that enables it to do same task or task drawn from the same population more efficiently and more effectively the next time. It means the same data is being repeated to get trained to the machine. And once the machine will learn the data, so here population itself means the data. So here once the machine will learn that population or the data, and again with more and more learning, the machine will start working efficiently and effectively every next time. Such as initially, like the child is having the new things in the class. So first time the child will feel a little bit tough while learning that particular module which teacher is training. Later on, the second time, the same chapter, if the teacher is teaching, so child will feel certain, little bit relaxed, because some of the things the small child has learned earlier. Then if the teacher repeats the same syllabus or the chapter third time or fourth time, so surely the child will feel more and more comfortable because they had already learned that points and they are just revising those things. So more and more learning will come as more and more data in the similar way we deliver to the machine. So machine will start responding well with more and more learnings. Okay. So we can simulate the machine learning just like the child learning. So the way the child is learning slowly, and at one day the child will create the knowledge and child is able to give the test as well. In the similar way, machines can also do. Machine will learn the data and machine can deliver us the test also. Now, when we talk about the machine learning, there are types of machine learning. Those types are supervised learning and unsupervised learning. So we can see it here now. Machine learning is divided into two. We call it the supervised learning and unsupervised learning. Now, supervised learning is divided into two. So, first of all, let's see the supervised learning. Supervised learning means if I simulate the same supervised learning with the child learning, so we can say the small child is there and child is learning under the supervision of the teacher. Under the supervision of the teacher. So this is a teacher and this one is the child. So we can say here the child is learning under the supervision of the teacher. So supervised learning is the same one here. That there is a supervision provided inside the supervised learning with certain output. We'll be learning supervised learning into the depth slowly by slowly. Now let's move ahead here. Supervised learning is divided into two. The regression and the classification. When we talk about the regression, it means we are talking about here we are talking about the continuous valued data. For an example, suppose I want to see the electricity bill. I want to work on to the electricity bill, or I want to predict the house prices. So I can say electricity bill, house prices, school fees, doctor fees. So house prices, electricity bill, school fees, doctor fees. So these all are coming into the regression because the amount for the bill is into the continuous valued data. Continuous value data such as suppose one is getting the bill. Suppose one is getting the bill for, here we can say one is getting the bill of 569.2. So this much bill means 0.20. This much is the bill coming for the electricity. Suppose house prices is there. So house prices one is getting, suppose 79 lakh rupees. Okay, 79 lakh something, right? And certain paisa. So decimal systems are there. Decimal system is there. Decimal system is there. But whenever you submit the fee, certain decimal system is there, point system is there. So that one comes under the regression point. Suppose I am measuring the temperature. So temperature again comes into the decimal system. So that one is the regression basically. So regression works with a continuous values. whenever my output is into the form of continuous values. So there the regression will start working. Now regression will work into two. Here it will come with a linear regression, and second one it will come with a logistic regression. So it means machine learning has two parts, supervised learning and unsupervised learning. Whenever we are talking about supervised learning, again that one is bifurcated to the regression and the classification. Basically, supervised learning is available whenever we are having the output label. We'll be discussing into the detail now supervised learning. Supervised learning is divided into two, regression and the classification. Whenever we are talking about the regression, it means we are working for the continuous values output, such like the electricity bill, house prices, fees, temperature we are measuring. So all the values are coming into the decimal format. For such cases, we can work with a linear regression. Linear regression means all the outputs we are looking for the decimal format, continuous values output. Okay. Whenever we are working with a logistic regression will come with the output into the format of yes and no, into the categorical data, such as true or false values only. So one can see the difference here, that linear regression is working with the continuous values, and logistic regression is working with yes and no values, true and false data, only with the binary data. Now here, one more is there, classification. Classification will work when we are having 2 plus categories. 2 plus categories. For an example, suppose here I am having different colors. I am looking for the different categories. I am looking for the different colors, red, blue, green, yellow, pink. So these are the different categorical color. So in such type of situation where I'm looking for the different categorical data as an output, so there I can just work with the classification. So now let's start with the regression here. Let's see certain more points here. So basically there are two types of learning, supervised learning and the unsupervised machine learning. Supervised learning is working whenever the data points have known outcomes, and unsupervised learning where the data points have no outcomes there. Now how we can see it here? For an example, suppose here I'm having a data. Suppose here I'm just taking one of the data here. Suppose there is the number of hours and the grade. Suppose there is a kind of a data I'm having where the student, this one is the number of hours for the study. So I'll just say study hours. It means there is a kind of data where study hours are provided. Suppose 4 hours, 8 hours, 12 hours, 14 hours, 16 hours, 20 hours. These are the number of hours the student is studying. And let's take it out the grade now. So 1 grade. If student is just giving 4 hours to the study, the student is receiving 1 grade. If the student is giving more time to the study, the student is having 2 grades. If student is giving 12 hours to the study, the grade 1 is improving. If student is achieving 14 hours for the study, the student is getting 4th grade. If student is putting 16 hours to the study, student is getting 5th grade or 6th grade. It means we can see that as more and more number of hours the student is going, the student is also going with the number of grade. So here we can see one thing. Suppose I plot such kind of data. Okay, so it means whenever the number of hours is there and the grade is there. So if I plot this data, so I will be getting all the data in increasing order. Means I will be getting all the data here in increasing order in this way. Because as soon as number of hours is increasing, correspondingly grades are also increasing. So I will be getting the improved grades. So I will say that student is improving with the grade when more number of hours are one student is putting. So I will say that what is the correlation between the number of hours and the grade. So I will say here by looking such graph or plotting here, I will say there is the positive correlation between the data, because here I can see the data is growing. It is a positive correlation. It is showing if student is learning with more number of hours, we are getting the good grade. It is showing positively, right? So in this way, we are giving the supervised learning. And inside the supervised learning, we are providing the regression here. Because here, what we are looking for the grade that how much is the grade one student is getting when these number of hours are provided, right? Now what I can do, whenever we are talking about the supervised learning, so there are two things. Like one is so like we can take a case now. Whenever we are doing the supervised learning, every time during the supervised learning, there are the output. There are the output. How? Suppose this is the case here I am taking. One is the input and another one is the output here. So I'll just say it as the input and I'll just say it as the output. Input, output. So here I can consider the number of hours the student is putting. That one is the input. And the grade one which student is getting, that one is the output here. So simply I can take it here, these values. Suppose here I'm saying 8 hours, 12 hours, 16 hours, 20 hours, 24 hours, 28 hours, 36 hours, 40 hours, 45 hours, 47 hours. So correspondingly grade is increasing. Grade is increasing. Okay. So what happens during the supervised learning? This one. Why is the output here? So when we do the supervised learning in machine learning, we deliver the training data and the testing data. So we will divide this data into two. How? In this way. Means this much data, nearby 70% of the data we will send for the training, so that machine can learn this training. Training means it will learn the input and it will learn the output. So machine will check it out that, okay, if 8 hours one student is giving to the study, so 1 is the output. But when the student has improved for 12 hours, 2 is the output. When the student is giving 16 hours, student is improving with the output grade. When student is getting the 20 hours, more improvement is there. When student is getting 28 hours, student has improving very good. On to the 6th grade, the student is having the similar approach. One is getting into this way. So positive relation one is getting here. Now the point is here that whenever during the supervised learning in machine learning we are doing, every time we provide the input to the machine and also the output. So one can think it in the way, suppose here one can consider that input is a kind of like a question and answer. Question and answer. Question and answer means like the student is having a question and student is asking the answer, means answer. So student is learning the question answer, question answer, question answer, question answer. Once the student has learned all the question and answer, so his training phase is over. So I can say that like 70% of the data is given to the training, and now the terms comes for the testing. Now rest of the 30% data will be delivered for the testing purpose. It is just like we can assume that whenever the child has learned the question answer, now it is the time for the testing. And whenever we are going to deliver the testing, only questions are given. In real time also, whenever we are giving the test to the child or to the students, so only we deliver the questions. So these are the actual answers. These are the actual answers. So we do not provide these answers to the student. What is that? This is the actual, we'll hide it. So we will only deliver these questions to the student during the testing phase. Student will start responding the answers for this questionnaire here. So those answers which student is responding, that one is a prediction answers. Those are the predicted answers. So I'm just repeating few things here, that here that during the training phase we do provide the input and the output here. We do provide the input and the output here. So every time whenever we are working with the supervised learning, so we are providing the input and the output, just like the question and answer. So question answer, during the training phase, the machine is learning. So machine will be learning all the data of input and output. Now the training is over. Now it's the time for the testing. And during the testing, 30% of the data is provided for the testing. So during the testing, we are only providing the input, only the questions. And now it's a time for the machine, because machine has already learned with these two data. Now machine will start responding as the predicted answers. Now this answer and the actual answers will be matched, whether the two answers are the similar or having certain gaps. If gaps are there, so it means certain few errors are there. So into the supervised learning, there are the training phase and the testing phase. We call this testing phase as the prediction phase as well. Prediction phase as well. So the same is here. The same is here. That supervised learning is there and unsupervised learning. Whenever we work with the supervised learning, data points have no outcome. Data points means whenever we pass on the data set, so there is an output data. But whenever there is an unsupervised learning, we do not provide any output data. So we'll be learning it slowly. So supervised learning is basically the program is trained on the predefined set of data of correct answers or training example, which then facilitate its ability to reach an accurate conclusions. In unsupervised learning, the program is given a bunch of data that must find out the pattern and relationship within the data, but there we are not providing any output data. Whenever we are working with the supervised learning, inside the supervised learning, there are two categories, regression and the classification. Regression works with the output types or the continuous valued data. Classification will work with the categorization of the data. Now, as I had told you here that here, whenever we are talking about this machine learning, and inside the machine learning, like two categories are there, the supervised learning and the unsupervised learning. Inside the supervised learning, regression is there, and inside it there is one more classification. Inside the regression here, inside the regression, linear regression is there. Linear regression is there. So now let's check it out that what is a regression and what is a linear regression now. That how this linear regression works basically. So now let's work with the linear regression here. Linear regression model is a relationship between a dependent and independent variable. The independent variable is known as predictor variable and dependent variable is known as response variable. So we'll be continuing with the linear relationship in next now.